All right, ladies and gentlemen, you're going to want to grab your notebook and a pencil or pen and probably some colored pencils or highlighters. We're going to be filling out some of those proof tables again today, and these can get a little confusing, but I want to walk you through several examples, and I want you to write them all down so that you can follow along. Okay? We've been talking about triangles and their congruence statements, how if we know two triangles are identical, we should be able to know that all their angles are the same and all their sides are the same. Well, there's a way to do it without having to prove all sides and all angles. There are a few shortcuts, and I want to teach you those shortcuts because they will make your life easier, but you do have to write these down. So the first thing I want to talk about is ways we can prove triangles are congruent. Okay, and there's 5 ways. The first way we can prove triangles are congruent is by recognizing that all their sides have a match. We call this the side, side, side method. What this means is if we know that this side is the same as this, there's one match. And if we know this is the same as that, that's our second side match. And if we know this is the same as this, that's our third side match. So side means there's one set of sides, 2 sets of sides, 3 sets of sides have a match. That would be side, side, side. We will look at examples of each of these as we go. I just want to give you these pictures first of all. So write this down. Side, side, side would mean all the sides have a match. If you need to pause the video so that you can draw and I'm going too fast, please just pause it and you can resume it whenever you're ready. The next method is called side, angle, side. Now, these words are given in a certain order to help you. This says that this angle will touch both sides. The side holds hands with the angle, and this angle holds hands with this side, meaning the angle is between the 2 sides being talked about. Remember, an angle is a corner, okay? So if I say this angle, maybe we know those 2 angles are the same size. To have side, angle, side, we would have to know that the sides that are adjacent to it, this one and this one, and this one and this one, this makes side, angle, side. Notice how if I highlight this side and I highlight this side, they come together at the angle. The angle holds the 2 sides together. So side held together with an angle to another side. So the angle is between the 2 sides. It touches both sides. Another one we're going to look at is angle, side, angle. This time we're talking about 2 angles which are connected with a single side. So it's different than the one above. So if we're looking at this, we're talking about 2 angles. So let's just pick 2. Right? 2 angles that are connected to each other with one side. So if I were to talk about this side, so this would be an angle, side, angle connection, where it's angle connected to another angle with a side, where the one above it was a side connected to another side being held together with a single angle. So make sure you draw these pictures. You're going to need these. Another method we use is called angle, side, angle. So let's see if we can put the logic together now. Okay? Angle, angle, side. So we notice that there's 2 angles, but a side does not connect them. It's a side away. It's not between the 2 angles. Where the one above says the side is between the 2 angles. This time the side is off to the side. So let's pick 2 angles. There's my angle, angle. Now, the side cannot be between them. Okay? Otherwise, they would have put the word side between the angles. They did not. They put the side away from the angles. So I need to pick one side that is away from the angles. Okay? So this would be angle, angle. Notice the side's not between them, the side is away. The last one that will work to prove that two angles are the same is hypotenuse leg. So in all these other rules, we needed 3 objects. This time we only need 2. If we know we have a right triangle, and we know that this hypotenuse matches this hypotenuse, then all I need to know is that one other leg matches. Let's confirm this. You know this hypotenuse matches this hypotenuse. Then if I know one other leg, that's all I need. Okay? So these are the ones that work. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side off to the side. And hypotenuse leg. One rule that we're going to use is if we've proven one of our 5 rules that we just talked about, then we can tell 2 triangles are congruent using the idea of corresponding parts of congruent triangles are congruent. Okay? I know that seems like a mouthful, but what it really just means is if all the parts, all the corresponding parts of a triangle match, then the triangles are probably identical, because if all their pieces are the same, the triangles better be the same, right? Right? If everything about something matches everything about something else, then those 2 objects are the same. We're going to see how this works filling out some proof tables. Okay, so let's look at this. We're going to have stuff like this. Now, when we do this, we go one line at a time, and we also color the picture. Okay, so please do it the way I'm showing you. All right, it gets difficult if you don't. So here's our given stuff. PQ is congruent to ST. PQ and ST. So those 2 are the same. Okay, how did we know? They listed it under given. Okay, let's look at another one. Here it says QR is the same as RT. QR is the same as RT. QR is the same as RT. Notice, I read it, I write it, I color it, and then I reason. How did I know? They gave it to me under the given line. So far, it looks like I have one side set. See, that's a side, right? So this is a side set. These were sides. This was a set of sides, so that's an S. So far I have 2 sides. The next one says R is the midpoint of PS. So I write it down. R is the midpoint of PS. R is the midpoint of PS. How did I know R was the midpoint of PS? They told me in the given line. All right? So that's all my givens. And they don't really tell me anything other than R is the middle. Okay, so that's really not a side or an angle. I really don't know, right? So let's look at what they have for the next line. I'm out of givens. Then they told me this. They told me that PR is the same as RS. So I'm going to mark that on my picture. PR is the same as segment RS. These 2 segments are equal to each other. Well, notice that's the same one that has to do with the midpoint, right? So how did they know? how did they know that these two pieces should be equal to each other? Well, the clue, ladies and gentlemen, is always going to be in the previous line. They told me midpoint. And we're smart people. We know that midpoint means something in the middle cuts something in half. So I knew the definition of midpoint. Since they told me R was in the middle, I know that the left part should equal the right part. That's what the definition of midpoint meant. So I defined that word. The definition of midpoint means those two pieces are the same. Now look, are these segments? Are they sides? Or are they angles? Those are sides. So look at, I have a side, side, side. So how do I know, ladies and gentlemen, how do I know that those two triangles are equal to each other? I know they are because they met the side, side, side criteria. That was a long one, okay? But that's how these work. You try to collect enough sides and angles to fit one of those 5 rules you should have written in your notebook. So once you look at a picture and you start collecting sides and angles, look back at your notebook to see which order meets which rule. Look again. So it tells me JL is the same as MN. So I write it down. JL is the same as MN. JL is the same as MN. And then I color it on the picture. How did I know? They gave it to me. K is the midpoint of JN. K is the midpoint of JN. K is the midpoint of JN. How did I know? They gave it to me. They also told me it is the midpoint of LM. So K is also the midpoint of LM. Now, let's think about that. If they told me midpoint, they want me to do something with that information, right? They wouldn't tell me if they didn't want me to do something. So if K is the midpoint of JN, there's JN in green, what does that mean? Well, it means that this is the same as that, right? So you notice the next line is JK is the same as KN. Oh, we were able to mark that because we knew the definition of midpoint. Same thing. If K is the center of LM, that means this must be the same as this. So look what they wrote in the next one. Those two pieces are the same. LK is the same as KM. LK is the same as KM. How did we know? Because we understood what midpoint meant. So let's look at our picture. JL and MN, that's one side. That's the yellow side. The green ones, the two green sides matched. So that's a side, that's a side. The two purple sides matched. So now I have a side, side, side. So I can say the left triangle is congruent to the right triangle using the side, side, side rule. Okay, let's try one from scratch. Okay? So if we're going to do this, grab a pen. Let's start from the very beginning. So I'm going to notice AC is the same as AD. So I'm going to record that. So I'm going to grab a pen, and I'm going to write that piece of information down. AC is congruent to AD. Then I'm going to color it on my picture. Okay, so I'm going to grab a highlighter. AC is the same as AD. Okay, so these two are congruent to each other. So I can highlight them, or I can put a little mark on them. Those two are the same. Okay. How did I know? Well, they gave it to me. I'm going to type given because my handwriting is going to kind of sloppy. Okay, they gave that to me. Right there, given. You know that, so write it down, color it on the picture. Why? Because they gave it to me. Okay, first of all, is that a side or an angle? Those are two sides. So we're going to write an S. That's a side. go on to the next one. CB is the same as BD. So that's given information. So I'm going to write it down. All right. So I'm going to grab my pen. I'm going to write it down that CB is the same as BD. Okay, now before I do anything, I'm going to go mark that on my drawing. CB is the same as BD. BD, right there. Okay, so I marked that. Notice there's segments, right? So how did I know? Well, they gave it to me. So that's given information. And is that a side or an angle? Those are sides. So I write an S. Okay. Now, say we have two triangles here, okay? Let me grab my crayon, because it's always fun to use crayons once in a while, okay? I have two triangles. I have this triangle up here, okay, triangle purple, right? And I have triangle orange down here. Two triangles. So far, those triangles have matching sides here with the black mark, and then matching sides here and here. Do those triangles share any other sides that they haven't told me about? Can you see one that they share that they didn't tell me about? Yeah, right here. They share this one. This line belongs to both the top and the bottom triangle. So I'm going to write this segment down. Now, they didn't tell me about it, but I recognize that to have a triangle, I need three sides. So I have AC, CB. Well, I must have a BA to finish that triangle. Same with the bottom one. AD, DB, and BA to finish that orange triangle. So they share that triangle. So I'm going to record that. So I'm going to say AB on the top triangle is the exact same length as, so it's congruent to, the AB on the bottom triangle. Okay, I know they're the same, okay? I know they're the same, but they technically belong, one of them belongs to the purple triangle on the top, and one belongs to the orange triangle on the bottom. But they're the same segment, okay? This is a rule we haven't really discussed. This is what we call the reflexive property. Okay? Reflexive property means it's one object that is shared by two things. AB is technically one piece, but two triangles are using it. And they're obviously going to be the same length because AB can't be longer on one than the other because it's one piece. We call that the reflexive property. So you might want to write that down. Reflexive means it's shared between two items. Reflexive means to be shared. But beyond that, we know that it is a side, right? It's a segment, so it's a side. So notice I have side, side, side. So to finish this whole problem, I need to wrap it up with the prove line. So I know that triangle ABC, I'm just copying from right here, is the same as triangle ABD. And which rule am I dealing with? Side, side, side. Okay, so that's how we'll fill out these tables. So let's look at another one. Okay, so let's start like we normally do. So J, M, and NL, we write it down, and then we mark it on the picture. J, M, NL. Angle JMN. So remember, that means between J and N with M in the middle. So J and N, M is the bending point. So it's talking about this corner right here. J to N, where it bends at M. is the same as LM bend at N. LM bend at N. So these two are the same. Okay, so they gave us those two. They gave us those two. So let's write those down. They gave me this. Oops. Holy smokes. Given. They gave me the two angles. Okay, so far if I'm collecting pieces, I'm a piece collector, right? This was a side, and this was an angle. And notice the next line tells me MN is the same as MN. They're identical, right? MN, MN, right? MN, MN, right here. So they're talking about this MN right there. It's shared between this upper triangle and this lower triangle. And we just talked about something that's shared between two shapes. We call that reflexive. So it's the reflexive property. It's identical on both sides. And then we record, is that a side or an angle? Well, it looks like it's a line. It looks like it's a stick, so I say S. Okay? All right, so now I have side, an angle, and a side. Now I gotta make sure it happens in the right order. So let's look at this. I've got a yellow side. I've got a blue side. Does the angle happen between the sides? Does it connect the sides? Or is the angle away from it? Looks like the angle connects them, right? So we'll say angle. So this would be a side, angle, side relationship because that's the order the pieces happen in. Let's do a different one. Let's fill one out here. Let's try again. So KM, MN. So I'm going to do KM, MN. Make sure you're pausing and writing some of these down. This is very difficult until you get the hang of it. So then we're going to write KM. I guess I should have done it in a different color. That's okay. Is congruent to MN because they gave it to me. It's very hard to write with a mouse, by the way. Okay. Given. LK and LN. LK and LN. So we read it, we write it, how did we know? They gave it to us. Colored on the picture. We should probably mark that this was a side and this was a side. Now we're looking for one more object. Do we know anything about any angles or do we know anything about any sides? Don't have any measurements. I have no markings. They don't tell me anything about angles. So even though they look the same, I can't guess that they are. So maybe I'll just stick with this thing down the middle. This thing down the middle would be LM. So the LM on the left triangle is congruent to the LM on the right triangle. And that's the same on both, so that's reflexive. Reflexive. And that is a side. So in the end, I can say these two triangles. Now I have 1, 2, 3 sides. I have a side, side, side. So I can say triangle, LKM, is congruent to triangle L and M because of the side, side, side rule. Okay, it'll work like that for the other rules as well. So you're just going to have to work yourself through. Remember, make a list and then figure out what order things are happening in.